Alright, let's talk about fine-tuning foundation models. You ever use an AI model and think, okay, this is good, but it's not quite what I need. Maybe it's giving answers that are technically correct, but they just don't sound right. Or maybe it keeps misunderstanding your specific industry, like medical AI missing key terminology, or a chatbot that sounds too generic for your brand. That's where fine-tuning comes in. Think of it like this. If pre-training is sending a model to general school where it learns a little bit of everything, then fine-tuning is job-specific training. It sharpens what the model already knows and teaches it exactly how you want it to perform. Now, fine-tuning can happen in a few different ways. Imagine you've got a new trainee at work. They've read every book in your field, but they've never actually worked in your company. They kind of get it, but they're missing the specifics. Self-supervised fine-tuning is like letting that intern read through internal documents to pick up on your company style and language. No labels, no training, just more exposure to your domain. Then there's supervised fine-tuning. This is where you actually show them examples like when a client asks this, we answer like this. You're teaching the model with real-world input-output so it doesn't just understand concepts, but the correct responses too. And then there's preference fine-tuning. This is where things get interesting. Instead of just telling the model what's right, you also tell it what's better. Like if you have two possible responses and one feels more human, more helpful, you train the model to prefer that one. This is the secret sauce behind models that feel natural and intuitive rather than robotic. Right, so fine-tuning sounds great, right? But should you do it every time? Not necessarily. See, fine-tuning takes a lot of resources. You need data, compute power, and people who really know how to train models. And sometimes prompting can get you where you need to be without all the extra cost. But there are moments when fine-tuning is worth every penny. Imagine you're building an AI assistant for legal contracts. Out of the box, AI might be able to summarize contracts, but if you need it to speak in a precise legal tone, you have to fine-tune. Or let's say you need AI to generate structured output like JSON for an API. If the default model keeps giving messy, unstructured answers, fine-tuning can train it to always follow the right format. Alright, but here's the catch. Fine-tuning is memory intensive. Running a large model already takes a ton of memory, but training it, even more. Ever tried opening too many Chrome tabs and watching your laptop slow to a crawl? That's what happens to AI models when they run out of memory. That's why we have tricks to reduce memory usage. One option, lower precision training. Instead of using 32-bit floating point numbers, we switch to smaller 8-bit numbers. Less memory, same performance. Another solution, don't fine-tune everything. And that's where different fine-tuning techniques come in. First is full fine-tuning, where you update every single parameter in the model. Super powerful, but also expensive as hell. Then there's partial fine-tuning, where you only update certain parts of the model while leaving the rest frozen. It's way more efficient and still gets solid results. And if you want to get really smart about it, you go with parameter efficient fine-tuning, PEFT. Now, PEFT is like hacking the system. Instead of changing the entire model, PEFT lets you add small tweaks, kind of like installing plugins on a web browser instead of rewriting the whole thing. One method, adapter-based techniques, tiny, trainable modules that plug into the model and adjust its behavior without messing with its core knowledge. Then there's LoRA, low-rank adaptation. Think of it like this. Instead of rewriting an entire book, you just add sticky notes with corrections. That's what LoRA does. It updates only what's necessary. Another cool trick, prompt tuning. Instead of changing the model itself, you modify the input prompts, teaching the AI how to respond just by changing how it interprets your instructions. And there are two types. Art prompts, actual words written by humans. Soft prompts, hidden, trainable prompts that steer the model's behavior behind the scenes, and there's quantized training, which is just a fancy way of saying compressing the model to make training cheaper and faster. So if you're thinking about fine-tuning, where do you start? Simple, start small. Before you spend crazy money on fine-tuning a massive model, test your methods on a smaller one first. Try efficient techniques like LoRa or adapters before going all in on full fine-tuning. And remember, sometimes just tweaking your prompts can do the trick. At the end of the day, fine-tuning is what turns a generic AI into your AI. It's how you make a model truly yours. And that's a wrap for this deep dive into fine-tuning foundation models. If you found this interesting, stick around. There's so much more to explore in AI engineering. And just a quick note, this video is based on my personal interpretation of AI engineering, building applications with foundation models by Huyen. It's not an official summary, just my own thoughts and takeaways. Alright, that's it for now. Catch you in the next one. Thank you for watching. If you found this video useful, don't forget to like, subscribe and share.